Alright, next we're going to discuss matrix multiplication. This is where you actually multiply two matrices together. Now it's not going to be like the other operations where you combine corresponding entries. Instead, we're going to do a completely different pattern to matrix multiplication. Okay, basically we're going to multiply each entry in a row of the first matrix by the corresponding entry in a column of the second matrix. And then we're going to add all those products together. Okay, so it's going to be kind of a lengthy process, and it's going to look really strange, I think, at first. But I will walk through this slowly a couple times until you get the hang of it. Then you repeat for every row and column combination. So it's kind of an interesting idea. Let me give you a quick example. Probably the most basic example is to look at a row matrix times a column matrix. Remember, in the definition here, you take a row and multiply it by a column, essentially. Okay, so I'm going to start with a row matrix. Let's go with maybe 1, 2, 3. And then we'll multiply by a column matrix. Now it has to be basically the same size. The column has to match the row so we can get the right entries in here. So maybe I go -2, -4, and -1. I don't know, we'll just throw some negatives in there. Okay. So what we're going to do then to multiply these is we're going to construct a matrix. Actually, yeah, construct a matrix. And this matrix is going to be the product of a row by the column. And so whenever you multiply a row and a column, at least with this definition, you take the first entry of the row times the first entry of the column, then the second entry of the row times the second entry of the column, third entry of the row times the third entry of the column, and then you add all those products together. So we would go 1 times -2 plus 2 times -4 plus 3 times -1. Okay, and that will get us, if we simplify it, a matrix containing the number, let's see, that's -2, that's -8, that's -3, that'd be -10, -13. And that's just a single number in that matrix, a 1 by 1 matrix. Now what we've started off with is a 1 by 3 matrix, and then we had a 3 by 1 matrix, and we ended up with a 1 by 1. Now the 1 by 1 matrix, it's interesting that the 1 and the 1 match the 1 and the 1 row, 1 column from the original two matrices. What you'll find in matrix multiplication is that in order to make this a valid operation, the size of the rows must match the size of the columns. In other words, if there's 3 entries here, there's got to be 3 going down. So the number of columns, 1, 2, 3 columns, must equal the number of rows in the second 1, 2, 3. So these two numbers here must match in order to get a valid matrix multiplication, and the final answer will contain the size of the outer two numbers, the two that aren't used. Okay, so let's take an example that looks a little bit different, a little bit bigger. Maybe the final answer is going to be a little bit bigger. So something like, let's go with 2, 5, -1, and 4. And we'll multiply that. I'll do another, let's see, we'll do a 2 by 2 again. Let's do 1, 3, 2, and -2. Okay, so on this one, again, we're going to want to do row times column, but we've got to do what remember I set up here, repeat for every row and column combination. So you're going to multiply first row, first column, second column, second row, first column, second row, second column. And those combinations will each be their own entry in the new matrix. Okay? So, let's line this up. Now, first of all, before I do anything, I should probably look at the sizes. This is a 2 by 2. This is a 2 by 2. Remember I said in the previous example, the middle numbers have to match up in order for the in order to get corresponding entries. So I have to have the same number of entries in each row as I do in each column here. Right? So there's 2 entries here, there's 2 entries here, I can match them up. The final answer is going to be the size of the outer numbers. It's a 2 by 2. Alright, so I know it's a 2 by 2, so I'm going to go 2 tall, and then I'm going to need 2 wide, but I'm going to need some space to write all these terms out. Okay, so as I multiply, I'm going to go first row, first column. That'll go in the first row, first column of the final answer. 2 times 1 plus 5 times 2. Okay, that's first entry, multiply together. Second entry, multiply together. Okay, then you're going to do the first row times the second column. That'll be first entry times first entry, 2 times 3. Second entry times second entry, that'll be 5 times negative 2. Alright, then you do second row, first column, that'd be negative 1 times 1, right? First entry times first entry, and then second entry times second entry, which is 4 times 2. Then we're going to do second row, second column. Again, corresponding entries match up. So negative 1, that's the first entry, times 3, that's the first entry. And then 4 times negative 2. Second entry of each. Now I said this is going to be a 2 by 2 matrix, and you can see once I simplify each of these, there's 4 different things to add together. That's going to be our 4 different terms. Alright, so now, and also just a note that I repeated this for every row column combination. First row multiplies first and second columns. Second row multiplies first and second columns. That gives us all the combinations. Right, now when I add these together, 2 times 1 is 2, 5 times 2 is 10, 2 and 10 make 12, 2 times 3 is 6, 5 times negative 2 is negative 10, 6 minus 10 is negative 4, this is negative 1, this is 8, that'd be 7, this is negative 3 and negative 6, no, I'm sorry, negative 3 and negative 8 make negative 11. Okay. So again, we have a 2 by 2 matrix in our final answer. Alright, so hopefully you can start to see where those combinations are coming from.